Well, it's been quite a while since the last video log, but not through want of effort. We've invested 500 hours of work in the aircraft since the start of July alone. Unfortunately, the aircraft was not quite ready to fly at the end of this summer, but there's been a lot of work done, and I'll give you a quick guided tour as to what we've been up to over the last 4 months since the aircraft came back from RAF Marham, where it was painted. So the most obvious change over the last 2.5 months has been the fitting of the wings. Fabricated in the factory, they fitted beautifully, but it still took 5 of us a whole day to get them in and to get the 8 bolts through the spar box, which is part of the fuselage, through the wing spars and then torqued up. And with the wings now on, that gives us the ability to put the flying control surfaces, which are the ailerons, onto the aircraft, and also to fit the flaps, which are there to enable a slow takeoff and a slow landing. The flaps have been fitted but have been removed just for ease of access. And because we've now got the ailerons fitted, it's enabled us to connect all of the flying control surfaces which terminate in the cockpit. And concurrent with everything else has been the wiring of the aircraft. An unbelievable amount of wire has gone into putting this glass cockpit into the heart of the aircraft. Each one of these screens has got at least 1, maybe 2 of these connector blocks at the back. Each one of those has got a dozen, if not 2 dozen wires that come from that to various parts, various sensors and other avionics around the aircraft. So an incredible amount of work has gone into it. Ordinarily, you just see this part of the instrument panel when you're flying an aircraft, for example, the circuit breakers, but you only realise how much that goes into it when you turn the panel the other way around and look at it from the back end. But really excited about this. The panel is really taking shape now. It has been fitted to the aircraft for the last time, and I'm just waiting for the avionics to go in over the next couple of weeks and for us to test run the avionics to get a really good idea of what it's going to look like sat in the hot seat, which I'm kneeling in at the moment. So with all these fantastic Garmin avionics completely filling this instrument panel, I've had to find somewhere else to put some of the other essential control services for the aircraft. So in particular here I've got the engine controls and the propeller control, then the air controls. I've then got a couple of emergency switches, 2 clocks and the controller for the emergency locator transmitter. All of these are on the center console, which then bridge the gap between the bottom of the instrument panel and the top of the fuel selector valve. And one of the most obvious differences between this and a standard RV7 is the first of the long-range fuel tanks, which has gone into the cockpit. There is 80 litres of fuel which goes into the right-hand footwell, with a further 160 eventually to be fitted into the right-hand seat. This has been wired and plumbed into the aircraft and is the first of the real long-range modifications to have been fully incorporated into the aircraft. So this is the snorkel, named like that for obvious reasons, and this directs filtered air from the air intake, compresses it and accelerates it, and then gives it to the fuel injection system under pressure, which increases your manifold pressure, which then gives you better performance of the engine and better economy. But with safety being the priority at all times, if this system gets iced up, then there's a control in the cockpit which I pull, which then opens a trap door and gives me ambient air, which bypasses any blockage that it might have to allow the engine to continue running. So these yellow things here are baffles. There's been a huge amount of work invested in these, probably 2 weeks total, in order to cut them down and get them to just the right size and get them fitting nicely across the entire engine. We've just got the 2 fitted on the front at the moment just to show you how it works. The air comes in through the engine intakes, which is on the front of the cowling, and is then guided over the top and then down through each of the cylinder fins to make sure each of the cylinders gets cooled by the same amount of air. So how this works is we cut this rubber strip, and that's then riveted on to the top of the baffles, with the back baffles being there. And that ensures there's then a nice seal from this plenum area to the area below the top of the cowling, which ensures that there is no leaking air, because any air that leaks is wasted drag, and any wasted drag slows the aircraft down, which we can't have. One of the things we're looking at the moment is just tiny little aerodynamic clean-ups and tweaks to it, just to ensure that we are optimising the airflow over the aircraft. One in particular is here, just to make sure that we've got a better fit between the wing skin and the tip tank. The tip tank itself is very, very difficult to fit because it's got a lot of internal ribs. There's no flexibility on it, unlike the standard wingtip which would come with a Vans RV7. So what we're doing at the moment, unfortunately after it had been painted, is just building this up to ensure that we've got the most aerodynamic finish to the airflow as it goes over the wing. So one of the great things about building a home-built aircraft is the ability to customise it to your own personal application. And the example here that I'm using is the fuel pipe system that takes fuel from the outboard and the inboard tanks and then provides it at the right amount and the right pressure to this very, very high performance engine. What you see here is the routing of the fuel from the inboard tank through a gascolator which removes any debris and any water that happens to be in the system, and is then delivered to the fuel valve which is in the cockpit, which then gives me the ability to take fuel from tanks to balance the aircraft and to ensure that I use all of the available fuel in each of the available tanks. I'm really pleased with the outcome. As you see in front of you, I think it's as near as perfect as possible, and it is tailor-made for this particular aircraft, in particular the way I need to control the fuel flow and supply high quality fuel which is clean and water-free to this very high performance engine. The only downside though is the immense amount of waste that has gone into producing this system with this very, very expensive aluminium pipe, majority of which now will end up in the recycling. So you can't get power without heat. The downside to that is the exhaust gas temperature coming from this engine is somewhere in the region of 600 degrees Fahrenheit. The radiant heat coming off of the exhaust pipes, which go very, very close to the inside of this fiberglass cowling, can damage the material. Hence the requirement to heat-proof it inside with this reflective material, which has the capability of reflecting radiant heat up to around about 1000 degrees centigrade. So the decision to delay the event by 12 months was very, very difficult, and it was a very disappointing outcome. However, overall, I think it's a bit of a no-brainer, and it has given us the opportunity to really concentrate on the logistics and the flight planning elements that will make this a really successful world speed record attempt. I'd like to thank everybody for their continued support. Over the winter months, please do continue to log into the website, the Facebook page and the Twitter account for the exciting updates of the Flight of the Navigator project. I'll speak to you soon.